it still is one object. It didn't break up. And moreover, there is a glow extending towards the sun again, anti-tail, opposite to what you expect for comets,
Huh.
where the tail is being pushed away from the sun by the solar radiation pressure and the solar wind. Here we see it going towards the sun.
No fireworks were erupting behind the sun. 3I Atlas has not been torn apart by any force, natural or otherwise. In particular, this latest information was also reported by leading Harvard University professor Avi Loeb. What we are looking at is a single intact object attached to a mysterious beam-like jet pointing straight at the sun, a complete contradiction to what scientists believed just 48 hours earlier, that it had been expected to explode into 16 pieces. Our confidence in explaining this comet with normal physics is collapsing. So how should we understand it now? In this video, get ready to meet the new equations that may rewrite what we know about interstellar objects. First, I want you to look closely at these extraordinarily detailed images taken on November 11th by the Nordic Optical Telescope. What they show is astonishing. 3I Atlas appears as a single coherent structure. There are no cracks, no evidence of splitting, no faint streaks drifting away from the nucleus, and no clusters of debris. Nothing. What we see is a lone, intact object navigating the brutal, relentless heat of the inner solar system, behaving in no way like an object expected to break apart at perihelion. Astronomers David Jewett and Lane Liu have reached into the mystery from the Canary Islands. After repeated observations and countless spectral analyses, they still found no telltale streaks of broken fragments, no secondary objects, no remnants of anything that could be interpreted as a breakup trail. Instead, all they found were the spectacular, puzzling, sunward-facing jets that defy the typical behavior of known comets. I will show you those in detail shortly. But before we get there, I want you to notice the profound implication of what you are seeing. 3I Atlas has survived one of the harshest conditions of perihelion. Friends, support this channel with a like or follow. It helps more than you know. I promise the discoveries ahead are worth every click. And if you enjoy these deep space mysteries, I truly appreciate your comments. Scientists used every high-sensitivity technique available to reveal the true nature of this anomaly. With a 2.56-meter primary mirror, they imaged a 500,000-kilometer region around the comet, ensuring no escaped fragments could hide. At the time, 3I Atlas was about 1.43 astronomical units from the Sun and 2.16 astronomical units from Earth, 114 million kilometers and 320 million kilometers away. Then came the image processing brightness stretching to highlight faint emissions, contour line mapping to reveal structures of equal luminosity, false color imaging to differentiate subtle light intensities, and concentric ring analysis in which astronomers study the image layer by layer moving outward from the nucleus. Every method was designed to expose even the smallest fragment if it existed. Yet after all these techniques, after all this painstaking work, the result was undeniable and absolute. Nothing had broken off. No fragments, no splinters, no debris known at all, even across the vast surveyed area. What remained was a single intact interstellar object exhibiting a remarkably unusual tail that set it apart from typical comets in both structure and behavior. Thus, this is not simply a confirmation of an intact nucleus. It is a detailed, multi-method verification that 3I Atlas remains entirely whole. And now, as promised, here is what scientists revealed regarding the object's anti-tail structure, taking our Sun as a converging point to fly towards. Though unfragmented 3I Atlas exhibits two opposing tailsafe phenomenon rarely seen with such clarity. One is a bright extended glow that points nearly toward the Sun, offset by about 9 degrees. This feature is similar to what the Hubble Space Telescope observed in July 2025. The second tail extends in the opposite direction at approximately 301 degrees. Though fainter, it is noticeably longer and broader, indicating a powerful outflow of gas and ionized material. The anti-tail of 3I Atlas represents far more than a striking visual phenomenon. It provides a window into the intricate physics governing the behavior of interstellar debris. As tiny dust particles are ejected from the nucleus, their motion is subtly influenced not only by the comet's trajectory, but also by the pressure of sunlight. From our vantage point on Earth, this creates the striking impression of a tail pointing toward the Sun, revealing both the distribution of dust and the dynamics of particle ejection across the comet's surface. Meanwhile, the ionized tail extends in the opposite direction, responding directly to streams of charged particles from the Sun. Protons and electrons in the solar wind sweep the ionized material outward, producing an elongated structure that reacts instantaneously to fluctuations in space weather. Twists, bends, and variations in brightness along the tail reflect changes in both solar wind velocity and density, effectively encoding a live record of the interplanetary environment encountered by the comet. Together, the two tails illustrate the remarkable complexity of 3I Atlas as it interacts with external forces. The clarity of these structures, rarely seen with such definition, offers scientists an unprecedented laboratory to study the behavior of dust and ionized gas in extreme conditions. By analyzing the motion composition and evolution of these ejected particles, astronomers can not only infer the physical properties of the comet itself, but also gain broader insights into processes that are otherwise invisible within our own solar system. In essence, the tails of 3I Atlas serve as a natural experiment, providing a detailed, real-time view of phenomena that challenge and expand current models of cometary physics. This makes the object not only an extraordinary phenomenon, but also a pivotal subject for understanding the physics of bodies that have traveled billions of years across the galaxy. As 3I Atlas moves away from perihelion, it presents a structure that is both intricate and unexpectedly stable. What was once a celestial oddity has now become one of the most scientifically valuable targets in modern astronomy. But here's the question many of you are likely asking: if this object was so stable, then why did nearly every astronomer predict it would explode before reaching perihelion? Perihelion is the most sensitive point in the journey of any object in the solar system. The reasoning is simple, at least under ordinary circumstances. As a comet approaches the sun, its surface heats rapidly, causing volatile ices to sublimate. Gas pressures build beneath the crust. Jets erupt. Mechanical stress rises. Eventually, these forces can exceed the tensile strength of the nucleus, causing it to crack, fracture, or fragment entirely. This is why small and medium-sized comets, especially those with diameters around 5 kilometers, are considered extremely vulnerable during close solar approaches. There are two historical examples that reinforce this expectation. Comet Shoemaker-Levy 9 was torn apart by Jupiter's tidal forces in 1992, and Comet Ison disintegrated near the Sun in November 2013. Yet as of November 11th, the day the Nordic Optical Telescope captured the crucial images, 3I Atlas remained perfectly intact. Not only that, it was releasing colossal jets of material. According to calculations by Professor Loeb, the sunward jet extends nearly 1 million kilometers, while the antisolar tail reaches nearly 3 million kilometers. Under normal cometary physics, gas escaping at around 0.4 kilometers per second, the approximate speed of sound in gases at Atlas's solar distance would require continuous jet activity for 1 to 3 months to produce such massive tail structures. And it would require sublimating roughly 5 billion tons of carbon dioxide per month. Thus, the enormous size of the tails already appears disproportionately large compared to the comet's own nucleus, which he had previously estimated to be about 5.6 kilometers. According to his calculations, the amount of energy required to produce such intense sublimation would demand a far greater active surface area. Therefore, he proposed a new inference: the nucleus of Atlas must be 4 times larger than his earlier estimate, around 23 kilometers. And an object of that size would indeed be difficult to fragment even under the sun's influence, but size alone may not be enough to explain its resilience. There is another crucial factor: age. A July 2025 study led by Matthew Hopskin and collaborators estimated that 3I Atlas is between 7.6 and 14 billion years old, likely making it older than the 4.6 billion-year-old solar system and potentially the oldest comet ever observed. An independent analysis by Astor Taylor and Daryl Seligman in July 2025 placed its age between 3 and 11 billion years, broadly supporting the earlier finding. Together, these studies suggest that 3I Atlas may be a relic from the earliest eras of the universe, a primordial wanderer whose composition and behavior carry clues to conditions that existed long before our own system formed. In that timescale, the object would have wandered through interstellar space for billions of years, subjected to constant bombardment by high-energy cosmic rays. This exposure would bake the surface repeatedly, forming a hardened, carbonized, crust-dense, durable, and highly resistant to heat. In effect, 3I Atlas may possess a natural thermal shield forged over eons of cosmic radiation, allowing it to survive extreme solar heating. On the other hand, cosmic rays may have altered Atlas' internal structure itself. Over immense periods of exposure, high-energy radiation could gradually reorganize the material within the object, forming an outer layer that is brittle yet remarkably strong. It helps stabilize the inner core, allowing the comet to endure extreme environments and survive conditions that would easily destroy younger or less processed bodies. A third possibility favored by many scientists is that sublimation may be occurring in an unusual way. They propose that beneath the ancient outer crust of this interstellar object lies a network of gas channels or long-formed pressure pockets created over billions of years. When heated, these hidden pathways could allow gas to escape through controlled localized vents rather than explosively tearing at the entire structure. In this scenario, 3I Atlas can unleash powerful outgassing while avoiding catastrophic fragmentation, effectively relieving internal pressure through these natural conduits carved by time. However, even these explanations have still not satisfied everyone. Yes, there are always even bolder possibilities to consider. Leading this line of speculation is perhaps the very professor we often mention, Avi Loeb. He has repeatedly asked whether 3I Atlas could in fact be an artificial object, specifically a spacecraft of extraterrestrial origin. Loeb suggests that a technologically engineered propulsion system could at least in theory mimic the solar-driven jets we observe emanating from the comet. Such a mechanism, if intelligently designed, might produce sunward outflows that appear natural to conventional observation, while in reality being controlled or guided by an advanced technology. We cannot dismiss this notion outright. After all, the prior explanations remain at this stage educated scientific hypotheses rather than confirmed evidence. The extreme behaviors, unusual tail structures, and remarkable ability to exist intact of 3I Atlas challenge our expectations of natural interstellar objects. There is still something about this visitor that we do not fully comprehend, the way it behaves, how it interacts with solar radiation, and the mechanisms driving its unprecedented activity. For those of us who love gazing at the night sky, this is a reminder to remain open-minded. We must carefully consider what might be occurring with these exceptionally rare interstellar guests, not only in the present but also for future encounters. These objects push the boundaries of our understanding, encouraging both imagination and scientific rigor. The universe is vast, full of mysteries, and 3I Atlas exemplifies how much remains unknown. By observing carefully, questioning assumptions, and staying receptive to all possibilities, we prepare ourselves to witness discoveries that could transform our understanding of the cosmos.